What is going on, y'all? This is Comms Engineering, and in this video I'm going to show you guys how to install grill lights onto your vehicle. This specific video will be tailored to the Mazda CX-5, but this is a universal kit dependent on how your grill is. First step is showing you guys how to do it, and the next step is just writing out a electrical engineering diagram of how everything works in a blueprint. I will link it in the description, and let's get to it. So the kit in the description is going to come with 4 of these LEDs along with 2-pin connectors for those LEDs with power and ground. After that, you're going to need something called a fuse adder or a fuse tap. There are things in your car called fuses that are all designated to certain parts of the car, like the windows, the lights, windshield wipers, that kind of stuff, and it keeps the current regulated so that it doesn't draw too much power and destroy the car. Each fuse has a label on them and a number saying 10 amps, 15 amps, 7.5 amps. That is how much it can handle. So what I have in front of me is the same exact thing, but the difference is that you can add whatever circuit you want, such as the LEDs. So let's get started. An extremely useful tool for this project will also be a digital multimeter. You can test voltage, amps, whatever you need. We can just take off the screws and the clips that are on this side. We don't really need to. You can pick any side though, but we're gonna feed that light right there into that.
I'm just gonna go through here, let it go through here, and hide the wires under this plastic. That's why I loosen it a little bit.
Yeah.
Just connect it to the car.
Well, it's gonna connect to the fuse tap first.
Well, yeah.
Which is gonna be this right here. Fuse tap here. We got the amber lights. They're gonna be fed into that grill. So make sure the DMM is on voltage. Doesn't DC, of course.
Gotta put it on the ground first.
So the black lead is pointed to something bolted onto the frame, which is kind of like a reference ground thing. There's also a ground on the actual battery, like the pot red and black. The black is the ground. But basically, this is kind of where if you have too much power in a circuit, the ground is super necessary, that it dissipates the power along to like a huge metal frame, for example, such as the car or something else, just to keep that power from not over expanding. Ground.
And put the right over here.
And well, that's 12 volts.
That's 12.
Keep on switching them through.
There's 7 boys. 12. 12.
That last one right there, 0.
This one gives 0. So that's what we needed.
That is an ignition fuse right there. Not a constant 12 volt.
That's right.
So we chose this one. H/L low. Okay, so the kit already comes with a 7.5 amp fuse and a 10 amp fuse in the actual box that you guys saw in the beginning. Not these, but those are the ones that you're gonna need to stick in to. So yeah, you have a 10 up here and a 7.5 down there, and that's more than enough to handle the grill lights. And so we took out one of the blue ones that was here, and then we stuck these in, and then that simply just slots in to the fuse slot. So now you can actually test the lights with the ignition, an on and off test. To test it, we can simply put the red wire inside of this blue tube right here, then put it on ground.
So because it's on because the ignition is on. So if we turn off the ignition, the lights are off. You feel me?
So after you've got the fuse tap connected to the slot and the red wire connected to the blue tube of that fuse tap, we can go ahead and use these wire strippers or wire cutters to kind of like clamp them down or cramp them down. If you don't have this, then you can simply use like some sort of lighter. We're going to use a stove lighter here to make it shrink, because these are heat tubes, which means that they shrink under heat. So yeah. All right, after we shrink it, we're going to try to feed it through the grill. We've got a couple of plastic parts out.
You take this.
No, that's right.
Yeah, that's right. Look your hands.
All right. Once you have it through, feed it in. All right, to make it easier, we can disconnect the lights from them 2 pins. Grab your zip ties, because that's how we're gonna mount them on. Depending on your grill, if it has screws, then you're good, but if it doesn't, you're gonna need zip ties. So see how it looks beforehand. You might want to have one on top of the other, or you might want to have all of them in a single line. So this is what it looks like. Get someone with skinny fingers for sure.
You take it from here, you wrap it around someplace, preferably level with it, wherever the hell my fingers are way too fat.
Okay, once you have all of them zip tied, be sure not to tie it too hard. Don't be like me. For the final part of the installation, you're going to want to ground the wire for the LEDs. Here we're using an adjustable wrench to unscrew a bolt that is simply clamping down a bunch of black wires to the frame of the car. We are simply going to add the ground wire for the LEDs to this bolt. Alright, so here we are going to draw out the diagram for the LEDs. So we're going to start off with a voltage source, which is basically the battery, and this is usually all combustion cars have 14 volts, and all of the low, the car batteries are all around there. We're going to need LED. One is fine for now. Need fuse. Two of these. Alright, and then we're obviously going to ground everything. So for the LEDs, you can see like down here, it'll pop up anode, which is going to be on the positive side, cathode, which is going to be on the negative side. So this part is getting grounded. This part is just going to be incorporated in the circuit. The battery obviously has the plus, the minus, so the minus always goes to ground. Cathode goes to the ground. Positive is powering both of the fuses. Put these in parallel. Okay. This is the, so this is the fuse tap right here. The circuit analysis here. The first thing we're going to do is we're going to find what the current of the LEDs are. So here we're going to use something called the power formula. And this is going to be power is equal to voltage times the current. We don't know what the current is, so we can rearrange this. The current is equal to power divided by the voltage. Okay, so we have these two, because in the description of the kit that it comes with, we have the power dissipated is 5 watts, and the voltage that it's going to take is going to be 12 volts. So underline these two and color code them. Okay, 5 watts. Watts is the unit for power. Voltage, 12 volts. And the current is approximately going to be 0.42 amps. So that is the current of the LEDs. Now, we have 12 volts that this LED takes, but the total voltage of the circuit is 14 volts. So it's only going to pull 12 volts. So we're left with 2 volts when we get here. That means since the LED operates at 12 volts and the voltage source is 14 volts, we need to drop the excess 2 volts that we have. Now, we need to use a resistor, which I'm pretty sure the LED already has inside of it. All manufacturers add resistance in electronic components. You know, if you see phones, laptops, anything that you can think of that's electronics, it's 90% likely to have a resistor. 99%. So, we can use a resistor. We can use something called Ohm's law and figure out the resistances. So Ohm's law is going to be voltage is equals to current times resistance. So we have current and we have voltage, but we don't have the resistance. So what we do is, you guessed it, we rearrange it. So it can be resistance is equals to voltage over or divided by voltage. And let's color code them again. Let's do pink for the current. So for the voltage, it's not gonna be 12 volts, we're gonna use the excess voltage here. So let's bring it over here to 2 volts divided by the current, which is gonna be 0.42. So 0.42, this is approximately going to be 4.8 ohms. We do ohms for resistance. So again, the excess voltage is because we have a 14 volt voltage source, and this electronic component inside of the circuit only takes 12 volts. So that's how we can find out what the resistance of an electronic component is. So now for here, we have, for the actual fuse taps, we have the original fuse, which is the 15 amp one. In the video, I lost the 15 amp original fuse that we pulled out of the fuse box, so I just used the ones that are in the kit. but you're supposed to put the original fuse. We can write it out here, and then this is going to be the new. In this case, the current for the LEDs is 0.42 amps, so 7.5 is more than enough. So it's still using that original fuse. However, it's adding the 7.5 amps to the circuit of the LEDs. Usually you can't do this with just one fuse, just like a normal fuse that doesn't have that heat shrink tube and the power connector. So that's why you need a fuse tab. And there's some circuit analysis. Alright, that is it for part 1 of the grill lights. The next part of this is going to be adding a switch onto it so that we can manually turn it on and off when we're driving out and about, not just solely ignition on and off. We want to have that switch. So yeah, tune in on the next one, coming soon.